Greetings, my math Padawans. Today we are going to be talking about Chapter 5, Section 5.2, Area. And specifically, we're going to focus on the ability to find the area underneath of a curve. So, in this problem, what is the area underneath the line given by g of x, which is equal to 2x, between 1 and 4? Now, folks, if you remember back from the beginning of the year, we would call these definite integrals. Because remember, a definite integral is the area that is underneath of a curve. In this case, we're specifically looking for the area under the curve between 1 and 4. So if we look at that area, I'm going to highlight it here in the blue for us on the graph to the left. We are looking for that area right there. Now, if you remember back at the beginning of the year, we had a bunch of different methods that we were using before we actually knew a lot about terminology. In this case, we're going to kind of use some of the new information that we've come up with and some old stuff that we knew back from geometry to help us calculate what this definite integral is. First of all, we need notation. In order to note a definite integral, you may see the integral sign being used. We want to go between 1 and 4, so we will see an upper bound and a lower bound of 1 and 4 in their spots respectively with the definite integral. What are we finding the definite integral of? The function g of x. It's always important that we know the variable we're integrating with respect to, and until it's different, you're not going to know that that's going to be x. So my notation for what I'm about to find is here on the screen. We say the integral from 1 to 4 of g of x dx. Now, the way we're going to calculate this is the way we would use a geometry formula to calculate that blue area over there. And if you see, that blue area is in fact a trapezoid. So we have the area of a trapezoid, which if we remember, that is 1/2 base 1 plus base 2 times the height. In this case, that's 1/2 the first base. The first base is going to be this distance right here. So how is that? Oh, that's 2. So 2 plus the second base, what's that distance? All the way up here at 8 times the height, which is going to be this here on the side, which is, careful, not 4, 3 units. See, 1, 2, 3 units. Don't be confused. Just because it goes to 4 does not mean my height is in fact equal to 4. We'll go ahead and do the math here, and we'll end up with 5 times 3, or an area of 15 units square. Let's take a look at another problem. Ooh, in this graph, you can see that we have a line, a semicircle, and then 2 more lines to create this particular graph. We can still define a definite integral across a variety of different values here. Let's take a look at the definite integral from -2 to 3 of f of x dx. So in this problem, I'm going to go from -2 all the way to 3. That gets me this shaded region that I have here. And if I'm going to calculate that area, I'll have the area of a semicircle. I don't know, we'll just do a sub c. Plus, I have an area of a triangle. Okay, so how am I going to do that? So let's see here. That's 1/2 pi, the radius, which is 2, squared for the semicircle, plus a triangle, 1/2, let's see here, the base is 1 unit, the height is 3 units. So I'll go ahead and do the math, and I'll end up with, let's see here, 2 squared is 4 divided by 2, I got 2 pi plus 3 over 2. That would be the definite integral from -2 to 3. Let's do a different one. Let's say we wanted to take a look at the definite integral from -7 to 0, okay, of f of x dx. Okay, well, let me do that. Let me shade that area up here for us with a different color. So -7, which starts here, to 0, which would be all of that area right here. Now, this is interesting because you'll notice that part of my area here is, in fact, underneath of the x-axis. This area is negative. And you need to remember that. You need to remember that anytime we have area that's underneath of the x-axis, we have to treat that as a negative value. Now, the way I calculate this is not going to be any different. I still will do 1/2 the base, let's see here, the base of that is 1, 2, 3, 4, 5 units. The height is 1 unit. But the answer is going to be negative because it's underneath of the x-axis. Then we're going to add the area of that semicircle. Okay, in this case, it's a quarter of a circle, so 1/4 pi, and we still have that 2 squared. So my answer here is going to be pi minus 5/2, and that's going to be the definite integral from -7 to 0. When they're geometric shapes, it's easy. We just use our formulas from geometry that we know. When it's not something that's geometric, the best we can actually do is estimate area. We can't find exact values, but we can estimate area. And in this case, we're going to do and use some of the techniques that we used from the beginning of the year. We're going to simply use rectangles. And if you remember, we have a couple different ways that we can draw a rectangle from what we talked about. We can use what we call a right-handed rectangle, which is where we're going to take our values and draw rectangles that are drawn from the right point of each one of the intervals. So in this case, I would give you directions. I would say estimate the definite integral from 0 to 2 using 4 rectangles of equal width. So you'll see I took from 0 to 2 and I divided it into my 4 rectangles in this picture, cutting it in half at 1, cutting it in half at 0.5, and then at 1.5. And I've drawn my rectangles to the right. You'll see that I used the right point to draw a rectangle across, and the next right point and drew a rectangle across, so on and so forth. So the way I will calculate this is nothing more than adding up the series of areas of rectangles, which is area equals base times height, plus another base times height, plus another base times height, plus another base times height. Okay, so here we go. So we'll have a base, which is 1/2 here, times a height, which is, oh, thank goodness my graph said it, of 4.75. And I'll add that to another base of 1/2 times a height of 4, plus another base, which is 1/2, times a height of 2.75, plus another height of 1/2 times 1. I will add this all together and come up with the answer of 6.25. But our rectangles don't have to just be drawn from the right side. We could also use, now we did a left sum, a right sum, but that's not the only type of rectangle we can draw. As a matter of fact, if we take these points and shift them just a quarter of a unit to the right, we can end up with these values that are going to create what I call middle rectangles. They look like this. And a middle sum we're going to calculate exactly the same way, except we're going to find the values of these middle coordinate pairs. Now, folks, I don't know if you missed it or not, but this is just me simply plugging in 0.25 into my expression. So it would be 5 minus 0.25 squared. Now, it is worth noting that Desmos has rounded my numbers. So this is actually 4.9375. That's worth noting, 75. And the same thing down here, it's 4.4375, and that's 0.75, and that's 0.75. It just did some rounding for me when I typed this in. So when I calculate the area of these middle sums, I use A sub m. I'm going to calculate the same, the base, right? My base is still 1/2. Times my height, which is 4.9375. The next one, my base, which is 1/2, times 4.4375, plus 1/2 times 3.4375. And finally, my last rectangle, 1/2 times 1.9375. I'll add those together, and I'll come up with the answer of 7.375. So it's up to you to kind of maybe think about which one's more accurate, but right now, we're not going to know. It is worth noting, this value is different than if we add the average or find the average of the right sum and the left sum. It's very different. Please don't confuse the two. Middle sums are exactly that. We find the midpoint, create rectangles, and calculate areas that way. It, however, is not the most accurate method. There's an even more accurate method. We can use trapezoids. So if we use our same interval that we did before, the 0, the 0.5, the 1, the 1.5, and the 2, we can use 4 trapezoids of equal width to calculate the area under the curve. That looks like this. You'll see that each one of my trapezoids I have calculated. And I would go through and I would calculate the area of each trapezoid separately. So in the area, and I do A sub t, I know it's the 1/2 the base. Okay, the base is 1/2, right? And it's base 1 times base 2. So base 1 is going to be given by the height over here, right? That height is 5, plus this height over here, which I've calculated previously as 4.75. So 4 plus 4.75. That will give me the area of the first trapezoid, plus 1/2 base 1, which is 4.75, plus base 2, which is 4, times the height, which is 1/2. There's the second trapezoid, plus the next trapezoid, which is 1/2 base, which is 4, plus 2.75, which is the second base, times the height, which is 1/2, plus 1/2 base 1, which is 2.75, plus 1 times the height, which is 1/2. My goodness, add this all together, and we will come up with the answer. And I come up with the answer of 7.25. Hold on, 7.25 using my trapezoids. Whew. This is a lot of different ways that we can estimate the definite integral, and that's all we're doing. We're just estimating the definite integral from 0 to 2. We will, of course, look into this a lot more over the next couple sections in the book, but this is our starting point. So go ahead, take some practice, go through and do your homework, and if you have questions, we will address it next class. Good luck.